In 1969, the National Aeronautics and Space Administration's program of space exploration reached a dramatic milestone. 3 American astronauts made the first journey to the lunar surface. America's scientific and industrial know-how, plus the skilled management of a government industry team, combined to achieve the goal of landing on the moon. And at NASA's John F. Kennedy Space Center, Florida, the free world's largest rocket launch facility, the journey began. Constructed on 88,000 acres of former swampland, the spaceport is the major launch facility for the National Space Program. Some of the facilities, such as the Vehicle Assembly Building, are duplicated nowhere else in the free world and reflect the character of a facility designed to assemble, check out, and launch the massive Saturn V moon rocket. There are mobile launchers, for example, upon which the Saturn V is erected, checked out, and launched. They tower 440 feet, and each weighs over 10 million pounds. The crawler, a huge tracked vehicle, moves the mobile launcher into the Vehicle Assembly Building, where the lunar rocket is put together. On the same launcher, it is delivered to the launch site for flight. To accommodate the 17 million pound load, a special roadway was constructed, 130 feet wide, which extends from the assembly building to the launch pad over 3 miles away. In the Vehicle Assembly Building, stages of the Saturn rocket, which are manufactured in several areas of the country and shipped to the spaceport by barge and plane, undergo detailed checkout. This highly varied and complex procedure involves the giants of the aerospace industry as well as the smallest companies, and utilizes the most advanced technology and equipment which the nation can provide. Components of the space vehicle, including the Apollo spacecraft, are assembled vertically in one of the high bays in the assembly building. Then, the complete rocket is subjected to a computerized checkout. The Launch Control Center, adjacent to the Vehicle Assembly Building, contains electronic equipment to automatically monitor, control, check out, and launch the Saturn moon rocket. 5 miles south of Complex 39 is the industrial area, nerve center of the spaceport, where scientists, engineers, technicians, and astronauts plan and accomplish many of the operations associated with the pre-launch testing of spacecraft. At the Manned Spacecraft Operations Building, huge 200-ton stainless steel altitude chambers provide a simulated space environment for the 3-man Apollo spacecraft. Here, components of the spacecraft are carefully assembled and tested before mating them to their launch vehicles. Here, the fully suited astronauts participate in the tests which duplicate a mission in space, including the use of the many instruments and controls which are necessary to pilot the spacecraft. The lunar module, part of the Apollo spacecraft which actually lands on the moon's surface with 2 astronauts, also undergoes extensive tests. Later, it will be joined to the service and command module to form the complete Apollo spacecraft. Fully computerized acceptance checkout equipment in the same building automatically makes thousands of tests of the spacecraft and displays the results on electronic screens for engineers to evaluate. At the Flight Crew Training Facility, astronauts rehearse space missions with unique equipment. A maze of sophisticated electronic devices provides the Apollo crews with realistic spaceflight simulations. The use of film, slides, models, and computers allows technicians and engineers to duplicate any portion of a space mission or the entire trip to the moon and back. At the Central Instrumentation Facility of the spaceport, data from all the pre-flight tests and launches are monitored, analyzed, and stored for later evaluation. High-speed computers can receive the data at the incredible rate of 36,000 pieces per second, store 432 million bits of data, recall and print out processed information at 2,400 lines per second and transmit the information to engineers at various locations throughout the spaceport, the Marshall Space Flight Center in Alabama, and the Manned Spacecraft Center in Houston, Texas. Across the Banana River from the Space Center at Cape Kennedy, NASA's unmanned launch operations has launched over 500 rockets, which included 100 satellites, lunar, and deep space probes. In the Cape Industrial Area is Hangar AM, where the unmanned satellites and spacecraft are assembled and prepared for flight. Weather satellites, picture-taking sentinels which transmit their meteorological findings to weather stations around the world. Communication satellites, shrinking the distance between continents and promoting better understanding between the peoples of the world. And deep space probes which electronically investigate the universe and photograph the planets of our solar system. Many unmanned spacecraft were in direct support of the Apollo program. For example, it was through the eyes of Ranger 7, which crashed upon the lunar surface in 1964, that man was first able to see vivid close-ups of the moon. Later, more elaborate lunar spacecraft, such as the Surveyor, soft landed on the moon and transmitted thousands of valuable photographs and data about the composition of the moon's surface. Then, lunar orbiters circled the moon and photographed wide expanses of the lunar surface with amazing clarity, which greatly aided scientists in the selection of landing sites for the Apollo astronauts. Commenting on the nation's spaceport, the leader of the government industry team and director of the John F. Kennedy Space Center, Dr. Kurt H. Davis.
Here at the John F. Kennedy Space Center, we have established a truly operational spaceport, and we are daily meeting the challenge of space exploration. The huge Saturn V vehicle successfully launched 3 American astronauts on the historic first Apollo mission to the moon, and we have attained the goal set by President Kennedy in 1961 of landing men on the lunar surface in this decade. Our early efforts in rocketry were very small steps into space compared to our present-day program, but they were equally significant, and there were significant space achievements in their time. In 1958, with an elongated Redstone rocket called Jupiter-C, which was no larger than the present-day Apollo spacecraft, we launched Explorer 1 into Earth orbit and placed America into the space age. 3 years later, in 1961, the NASA team of dedicated engineers, scientists, and technicians prepared a Mercury Redstone rocket for our first manned spaceflight, Alan Shepard's short suborbital ride. It changed the course of space history and paved the way for the development of present-day manned spaceflight capability, which can send men to the moon and return them safely to Earth. The exploration and conquest of space for peaceful purposes to benefit all mankind are the goals of the National Aeronautics and Space Administration. Here at the nation's spaceport, each day, we are indeed accomplishing those goals with men, machines, and determination.
The space program has held the public's imagination since the very beginning and has increasingly focused attention on the Kennedy Space Center. In order to meet such growing interest, NASA opened a Visitors Information Center at the entrance of the spaceport. Colorful, informative displays, which include scale models as well as actual space hardware, give the public a fascinating first-hand look at the space program, free of charge. Conducted tours of the spaceport are available at moderate prices. The stops on these tours comprise sites of manned and unmanned launches, including the now famous one of Apollo 11, the first lunar landing journey. The rocket, which makes traveling to the moon a reality, is the massive three-stage Saturn V. The release of energy from just its first stage at liftoff is equivalent to 6,000 jet airliners operating at full power. The 6 million pound transporter, which lifts, levels, and carries the Saturn and its launch tower to the pad, requires almost 8,000 horsepower to perform its task. The careful, deliberate journey to the launch pad takes place at approximately 1 mile per hour. Once there, a large number of specialized personnel prepare the giant moon rocket for flight. A towering 402-foot mobile service structure, which provides access for technicians to all areas of the launch vehicle, is moved into place on the pad. Then the team of support personnel begin their work. Thousands of tasks involving electrical, pneumatic, safety, fueling, and optics are performed with great care. In the firing room, 3 miles from the launch site, a complete rehearsal of the launch procedure is conducted. Hundreds of technicians are involved in the countdown demonstration, which also includes fueling of all stages of the rocket and spacecraft. Dr. Davis, the spaceport director, and Walter Caprian, the launch operations director, supervise major tests and the terminal countdown for the launch of the Saturn V. Throughout the meticulous 28-hour countdown which precedes the launch, thousands of individual functions must take place, each one carefully monitored by skilled launch personnel. Electronic eyes play an important role in the checkout process. 60 television cameras, placed in strategic locations throughout the pad and on the launcher, allow engineers to visually monitor all critical activities. Meanwhile, the astronauts who are scheduled for flight make their final preparations. The space suits are carefully inspected as each astronaut dons his protective apparel. 3 hours before launch, the trio of moon-bound astronauts begin their short journey to the launch site. There, the Saturn V rocket stands ready, thoroughly tested and poised for its flight into space. All of the countless hours of preparing and testing the rocket and spacecraft now come into sharp focus. Spaceport personnel, performing the countless tasks which are required for the launch of Apollo, bring together a wide spectrum of skill and equipment to successfully launch the moon rocket. Long-range cameras to follow and record the flight. Electronic ground stations, which will receive communications and television pictures directly from the orbiting spacecraft. Highly instrumented ships, which are part of the worldwide tracking system, as well as planes for around-the-globe communications relay. As the countdown approaches the moment of launch, computers in the Launch Control Center take over the thousands of checkout functions. The flashing lights of the launch consoles indicate all is proceeding properly. And in the Apollo spacecraft, The astronauts await the moment of liftoff. Exploration of space. Man on the moon, launched from America's spaceport, has become a reality. Yet it is only a modest first step along the pathway to still other worlds. The accomplishment of the lunar landing is a tribute to the people of many skills and professions who made it possible. Space Center Director Dr. Kurt Davis reflects on the efforts of that team.
What I have seen is that it is largely an almost unbelievable dedication of literally hundreds of thousands of people who have changed their way of life to accommodate an ideal, fully aware that they are not doing it for themselves and not alone for the United States of America, but for all mankind. And they have dedicated a quite essential part of their lives to achieve this goal. Mankind has opened a distance to the moon and will use it to explore all that can be explored and exploit it, and at the same time develop the tools to go further out to the sister planets in our solar system and much later to other solar systems.